For the Meanline design in TURBOdesign Pre, we start by selecting the machine type, which is refrigeration cycle with centrifugal compressor in this case. And then the next section is cycle spec, where we can see that the cycle analysis module supports both single and two-stage compression with or without economizer. And here we can select single stage compression. And for the refrigeration cycle, a lookup gas table is adopted for real gas properties, which can be read in from an RGB format file created from the NIST database. And then here you can define the cycle specifications, where superheating and subcooling effects can be included in the calculation. And the suction and discharge line pressure loss can also be specified. The next section is compressor spec, where we select the impeller, the vaneless diffuser, and volute components, since we are interested in designing the full stage. And then all that's needed is the rotational speed, and the rest of the duty point, such as the flow rate and pressure ratio, is automatically taken from the cycle analysis. Moving on to stage composition, where we specify some more details about the different components. So starting with the impeller, we need to specify the inlet up diameter, which generally comes from shaft strength considerations. It's also possible to specify the inlet velocity profile, the outlet velocity calculation method, and some optional parameters to impose various inlet and outlet dimensions and the number of blades. Now for the diffuser, we can also set some dimensions and the diffusion factor. And then for the volute, we can go with the default elliptic asymmetric section, which is commonly seen in chiller compressors, the fast linear calculation method, and set the dimensions for the discharge tube. Now we don't really need to change anything in the convergence parameters. And then we can run the calculation. And in a couple of seconds, we have the cycle diagram along with the pH and TS diagrams, where the refrigerant property changes can be visualized. And we also have this cycle summary report showing the refrigerant properties at the different stations and the coefficient of performance of the cycle. And then if we switch to the stage option, then we have the compressor flow path along with some basic dimensions and estimates of the efficiency, and the impeller RVT star, which is like its work coefficient. And as we scroll down, we have some more details on the individual components, such as the pressures and the velocity triangles as well. And then finally, with this button here, we can save all the files, which will later be used for the 3D inverse design of the impeller in TD1 and for the volute design in TD volute. And we also have these performance curves available, such as the stage total to total pressure ratio, the efficiency and coefficient of performance against the capacity. So this is the design point here. And you also get some idea of the off-design performance at other capacities and at other rotational speeds. And with that information, we can then proceed to the 3D design of the compressor stage.